Our first question, they have requested the following. They'd like an interactive dashboard showing profit by city, tied to profit by segment, and a profit trend. So let's go over to Tableau. Connect data. We'll go to Excel, and we'll connect to this African mobile data that they provided for us. We have two sheets, the salesperson and sales data that we had. We'll drag in sales data, and then we'll start to work. For our geographic fields, you notice Tableau has intelligently created a hierarchy that exists. We have country. We also then can drill in, and we have city as well. Notice we do have one unknown. Turns out that inside of African Mobile's data, they had just Congo listed. And if you come here and search for Congo, there's two options available. We'll just use the first one, and then that cleans up the city issue as well. So now the null indicator is gone. We have every city on our view. In order to visualize profitability, we want to bring in some profit, drag that on color, and then just to make this a little bit more readable and a little more stylized, we'll do a common trick where you drop the opacity or increase the transparency by a little bit, and then draw a border around that. Then we can up the size. And the nice thing about this is you can see when options overlap. You'll be able to hover over them and actually see what's going on. Along with this, we have our profit values. We want to change our default formatting a little bit. So rather than just being a straight number right here, we'll add in a currency. I'm currently based in the UK, and so I have to go through and make sure that I use the right prefixes. And then we have our decimal points that we'll include. For this purpose, we're actually going to just drop it to 0 because the decimal point isn't as important. And there we go. So now you can visually and quickly see on a map the distribution of profits by city. So for an easy one like Cairo, they made a profit of 142. They didn't tell us the units in this data set. My guess is it's thousands. And then for the city of Victoria, they've lost a similar amount, $144. So we'll call this our profit by city. Looking back at our request, we need to now see our profit by segment as well as our profit trend. So right here, this is a fairly straightforward graph. Profit segment. We'll come up here, change the size to fit the entire view. You'll notice that our default formatting for profit is carried over. We can then make this look a little bit better by adding some color, adding a label. And then if we want, we can mess with that to change it. But for now, we're just going to leave it by profit. Sorry, if I can type. Profit by segment. Then last thing is they want to see a profit trend. Generally, trends are done on a month level. They could ask for something different, so we'll need to make sure and ask about that when we return the deliverable to them. And now since they're also looking at profit by segment, then we'll include segment on color right here. So we can see the profit by month by segment. Again, a little bit of cleaning, come here to the axis. Month of date, don't really need the of date, so we can just change this to month. Then we have our profit. And we can rename this to profit by, profit trend, sorry. We already have a profit by segment. Now we have our three views that we're looking at. We have our profit by city, our profit by segment, and our profit trend. Now come down here and we create a dashboard. In terms of sizing, I generally like to change it to automatic. That way it takes up your entire view and it adjusts on the fly if new users access it on a different format. But depending on what you need, this device preview is also really nice where you can look at exactly how it will look on a generic tablet, on a phone. There's a bunch of different options. But in this case, we're just going to stick with the automatic. And sorry, let me undo a few steps there. And there we go. So the profit segment, let's add in our profit trend. And now to clean this up a little bit, we'll want to realign our legends just so we have profit matching up with the view that it's being used on. And we'll do the same thing with our segment legend down here, dropping it next to our profit trend. And so now we have a really nice looking dashboard. But this actually isn't everything that they've asked for. They want to be able to select a city on the map and see the other charts adjust. So in essence, we want to use this chart as a filter for our other two. To do that, you can come up here, click the drop down, choose Use as Filter. You can also just click this handy little button right here to use this filter. So using our cities from earlier, if we want to see Cairo, how they're doing, they're profitable across commercial, public, and residential, although they are trending downwards in commercial and residential, so that's worth looking into. Victoria is having trouble all over the place, but it's on a positive trend. So this provides us a lot more information than just this one static graph. Also provides the ability to highlight things and look through it. So there you go. We're about 5 minutes in, and we already have a nice interactive graph that shows not just our profit by city, but also by segment and that trend over time, and they all interact with each other. This is one of the main benefits of Tableau and something that really wows people when they see it for the first time. I remember when I was first exposed to Tableau, seeing this type of dashboarding capability compared to the raw PDF reports that we had that just got auto-generated and emailed and sent as attachments was like opening up a whole new world to me. And so it was incredibly exciting to see this kind of capability. Next, African Mobile has asked us for an interactive scatter plot showing the relationship between profit and sales by either region, country, or city, depending on their choice. So we want to create a scatter plot, but also want to use a parameter to make that choice possible. But coming in here, a few bits more of cleaning. Let's come and let's hide these sheets. And then we'll call this our profit dashboard. And these sheets are still available to us. If you zoom in there, then you can go to the sheet and you have access to it. It's just a nice way of cleaning up your workbook to have it hidden when you know that you just want people to look at your dashboard. So going back to our question, we want to look at profit. We want to look at sales. We'll change this to a circle, up the size a little bit, just so we can see things easier. Then we have a profit. We have our sales. We can go in with our sales. Let's just do a little bit of cleaning before we jump in. And currency, change this to dollars, and then get rid of our decimal places. And now we have our sales mapped against our profit. This two-way scatter plot is a great way to show the relationship between values, especially when you start adding more detail. So add a region into our hierarchy, and we'll add that on color. And now we can see the relationship between sales and profit for all 5 of our regions. Again, I said it's a very useful chart because immediately now we look at Western, and we know that they are the leader in sales, which on the surface would seem really good, but they're also the least profitable business out of any of our regions. So that's a great question to ask. You can also come down to Southern and Northern and say, okay, if you are selling so few in terms of sales, how are you making that much profit? So you can learn from best practices here and hopefully apply them here in your Western region to try and clean things up a little bit. But aside from the analysis, going back to the request from African Mobile, they want to be able to see the relationship between profit and sales, which we have, but they want to see it by either region, country, or city, depending on their choice. Now with this hierarchy, we could drill in, and now you see the country level of detail. You can drill in again and see city, but the colors aren't matching what we need, right? So you could do this, multiple clicks, adding in colors, then it starts getting really messy, really fast, really hard to read. Plus, then we have to rely on the end user to do all of this and understand and know how to use Tableau to that level. So what we're going to do instead is we're going to create a parameter that allows the users to choose what they want to see. So coming down here, we'll right-click, we'll create a parameter. This parameter is going to be called choose a dimension. As a best practice, whenever you want people to interact with your dashboard, it's best to create label names or parameter names that prompt that action. So choose a dimension. We want them to choose between region, country, and city. So we have these 3 values. Click OK. Show our parameter control. We have our new dimension that we're working with. We have a new parameter, sorry. And let me just get this bar out of the way. I'm going to come up here. I'm going to change it to a single value list. So now you can select between region, country, and city. We drag that up to color. That doesn't actually give us what we need. Because if you choose country, city, you notice that it's only returning 1 value and 1 color because that's all the parameter is telling us to do. So what we're going to need to do is create a calculated field on top of this that will then look to the parameter and pass through the appropriate field or dimension that we're looking for. So create a calculated field. Just use Alt-AC for a shortcut for creating that. We're going to call this chosen dimension. And we're going to use a case statement. So case, choose a dimension. When region, then we want it to bring back the region field. When country, we want it to bring back country. And when city, we want it to bring back city. For those of you who haven't used case statements before, you can think of it like an if statement. So if choose a dimension is equal to region, then we want region. If it's equal to country, then we want country. If it's equal to city, then we want city. Rather than having to type that equals each time and make that comparison, saved a few typing steps with using the case statement. So we now have our chosen dimension, and if we drag that to our color, we now have our region graph that we recognized before. We can then click on country, and you'll notice that it's updated not only with the new level of detail, but also our color scale has updated to show our new values. And then we have city as well. Now, built in this, we have a fantastic example of what's called an outlier. So we have our profit, we have our sales. Generally, they're pretty tied together. We have there's no strong relationship going on here, but there is some correlation. But then all of a sudden we have cartoon up here. They only have 17,000 in sales, but they're among the leading cities in terms of individual profit, 234. So this creates a great opportunity that we can see very quickly to go in and say, what are they doing? What are they doing well? And how do we replicate that in these other cities? So right here, we'll call this profit versus sales. And then again, we can come in, change the opacity to 80%, and add a little bit of a border, helping us see the circles that are overlaid on top of each other. Okay, looking at their third question, they're asking for an interactive salesperson analysis. So interactive, kind of another clue. They want either dashboards or they want some parameter they can select, showing contracts sold by each person, as well as a second chart showing the difference from a selected salesperson. So the hint was to go through and use bar charts as well as a parameter. And just kind of conceptually what we're looking for, I'll explain as we go through. So first though, right now we're connected to just our sales data. We need to go back to our data tab, create a new data connection to our same Excel file, except this time we'll bring in our salesperson data. Again, this has the date in terms of the quarter. We have each salesperson, we have the number of contracts they sold, and their close rate. But in this case, we're just trying to look at a comparison of contracts sold. Fit this to the entire view, and then we'll sort that. And so what we have is we have each individual salesperson. We have how many contracts they've sold throughout the entire data set. And then we want to be able to compare these people between them. So if we're looking at Aiden Morris, if we select him, we want to see that Priscilla Taylor had 5 more sales than him, and that Ken Railings had 70 less sales than him. That's the type of view we're going for. But in order to do that, again, a selected salesperson says use a parameter. We need to create the functionality so that our user can select the salesperson. So we can come down here and create a parameter, but then we'd have to type in every value by ourselves. If we come up here to salesperson, we can click create parameter. And what Tableau does is it intelligently chooses the data type and then provides a list of values based off of the values that are available under your dimension. So we'll call this choose salesperson. And then we have our list of salespeople to choose from. We can show that parameter control, and now we can select the values that we need. One quick note, in a lot of online questions and forums, you'll see people asking for dynamic parameters. That can mean a lot of things, but one of the things that it can mean is they want this to be able to update automatically. As it stands now, though, if you do this and create a parameter based off of it, you will have to manually add a new salesperson if you add new salespeople to your data. Just kind of a good best practice to know, because a lot of times you can have this parameter and then nothing new shows up, and you're scratching your head trying to figure out where your data went. Anyway, that was a bit of an aside. So now we can go through and we can select a salesperson, but we want to create a few calculated fields. The first one is just to find out our selected sales. So we're going to do if choose a salesperson is equal to our salesperson, then we just want to look at the contract sold. Nothing too complicated there. Bring out the selected sales into our view, and we have a challenge. What's happening is that for Francis, we get 151. That's exactly what we want. But if we look at Aiden, if we look at Audrey, if we look at anybody else other than Francis, it's returning a null. What's happening here? Turns out that this calculation that we're doing is one that is affected by the context of the view. So in other words, we're looking at our data. We can go through and we say, okay, for Alan Morris, sum up the contracts sold. It's 13. Great. But for selected sales, it's doing that if statement first. It's saying if the salesperson is equal to our selection, in this case, Francis Martineau, then sum it up. If not, return null. So it's actually returning no values. So how do we get around this? Starting in Tableau 9 and then expanding on its capabilities in Tableau 10, there's a feature called a level of detail calculation. These level of detail calculations make it possible to calculate data based off of data that's not in your view, and based off of a level of detail that's not in your view. Or you can exclude level of details in your view and then make it possible to sum up different values. So in other words, in this case, we want to be able to get this 151 without taking into account salesperson. So I'm going to call this level of detail, selected sales. And the syntax for this level of detail starts with a curly bracket, and then you choose either fixed, include, or in this case, exclude. Then you choose which dimension you want to exclude. So in this case, we're going to say salesperson. You put a colon, and then you tell it what you want to return. For this visualization, we want contracts sold. And then you close it off with a curly bracket. And let's visualize that and see what it looks like. First off, we have to go in and we have to fix a label. And now we have an error. This is great. This is something that will happen a lot because when you're trying to return selected sales, you want to make sure that it's tied to your parameter, not just your values in general. This is actually a good example of how level of detail calculations can return something funny that you're not expecting. So if you look at what this is saying, it's saying, okay, exclude salesperson, so don't take into account the fact that Audrey's here, and I want you to sum up all of your contracts that have ever been sold. In that case, it returns the sum of the contracts across the entire data set. So all told, we've sold almost 1,500 contracts as a company. What we actually want to do is return not every contract sold, but our selected sales that we calculated earlier. So now, if you look at Frances Martineau, she had 151 contracts sold, and we have 151 being returned for each individual value. This gives us exactly what we need to be able to go in and create a new calculation. So we'll call this difference from selected. And we will be able to say we want our sum of contracts sold minus the sum of our level of detail calculation. So we're saying we want this 203 minus the 151. Drag that up here, and we get the view that we're looking for. Again, we need to go in and change our label, because right now it looks kind of funny. And you notice this gives us exactly what we need. So we have Frances Martineau with 151, difference of 52 to Audrey Baker. Let's switch these right here and clean it up a little bit. We'll add color right there. I first ran across this on one of the tutorials that Tableau has posted, and I love the color palette that they used. They actually added one more feature to this, and it's a way to mark which salesperson you've selected, because right now as it stands, it's easy to see kind of the crossover between positive and negative, but if you have a lot of people who are tied, it can really mess with your visualization. So they came down and they created a Boolean where you got salesperson is equal to choose a salesperson. Basically, they're saying if our salesperson is equal to our parameter choice that we have, then we need to be able to show that and see that in our view. So if we drag that to color, we now have this built in, but we don't want the blue and the orange competing with what we already have. So if we come here to false, we can change that to white. To true, we'll change that to gray. And then we'll come back and just so we can see it, we'll add a border. And voila, you have a very beautiful looking view that shows a difference from our selected salesperson in terms of the contracts sold. And we can clean this up a little bit by hiding that card, editing the title, showing difference from selected. So we have our scale, and we have the interactive self-driven reporting that they were looking for. We'll call this our salesperson comparison. Okay. Fourth, they're asking for a two-way matrix over time, tracking salesperson quarterly performance against their company benchmarks for contracts sold and close rate. We have these benchmarks that we'll add in, and then we'll use the pages functionality to show the changes over time. So, coming in, we want to look at close rate. We want to look at contracts sold. And now, interestingly enough, when we look at this data, it actually doesn't make a lot of sense, right? So a close rate is a percentage. If you look back at our data that we have, close rate 0.55, 0.3, so 55%, 30%, 36%. and yet we're getting values above 50. What's happening here is rather than taking the average of a close rate or taking some other aggregation, Tableau is actually going in and summing up all those individual percentages. So we can change that if we want. There's a bunch of different options that we can use, but we'll just use average right now. We'll go in, we will format that, get it back to a percentage. We don't need the extra, that's right there. And then sum of contracts sold, we'll also drop that to an average just so we can see kind of your average salesperson percentage. In order to get the detail that we want for our view, we'll add salesperson to color. And we'll change this, again, to kind of our standard circle, up the size a bit so we can see how salespeople react, how salespeople compare to each other. And we've got a great view that shows what they've asked for, a two-way matrix tracking salesperson quarterly performance against benchmarks. We'll get back to the overtime bit in a second. First, we're going to add in these benchmarks. So for contracts sold, they want each person to be compared to 10 contracts. And then for a close rate, they want 30%. So this is a great example of where we can use reference lines. Reference lines can be driven by the detail in your view, but it can also just be a constant value that you pass in, which becomes especially helpful for benchmarks. So if we come up here, drag a reference line to close rate, we have several options. It could be driven by your close rate field itself, or it could just have a constant. In this case, we want it to be 30%. Notice the formatting carries over. And then we'll add another reference line to our contract sold, and we'll call that constant, and we'll bring it in on 10. Now, visually, this looks a little bit off in terms of this x-axis being a bit further than we want. Also, we need to format this to get rid of the extra zeros. Put it down so we have 10. And then I'm going to come in and just fix the axis really quick. Fixing the axis is a handy tool, especially when you know what your data looks like already, so you're able to create the view that you want. That being said, it is important to recognize that when you fix the axis, it will not change even when your data updates. So it introduces a lot of challenges. That it introduces the potential for things messing up as you look forward to the future. But now they want to see a two-way matrix over time. How do we show these values over time? We know what the averages are, and we know what they look like at this overall perspective. But the tip says use the pages functionality. If we use our date up here on pages, we don't show year, but we actually show quarter. We'll show quarter date. Now what we have is a page for each individual quarter. As we click through, we can see the dots moving across the screen to their different values, showing basically how that relationship changes over time and how the salesperson relative performance changes over time. Pages are a great tool to use. They're very handy in terms of creating a visually interactive view. You can also press play and it animates it for you. So you have your animated matrix that's moving around. You can increase the speed on it if you want. You can decrease the speed. Generally, I stick with just the suggested 2, but sometimes 3 is fun just to watch things bounce around. Now, while this is useful, at this ending point, what would be more useful is if we could see where they've been. So Priscilla Taylor, one of our top producers, at the end of 2016, has she always been this high? Or, for instance, Aid Morris, has he been here as well? So what we can do is we can actually come up here, show the history, and then we have a few options that we can use. We can do it for selected, manual, or all. In this case, we're going to do all. And you can either show the history for marks. I personally think that that ends up looking a little bit cluttered, even though it can look nice in some cases. I like using the trails. And then rather for the entire length, which shows every single mark in your view, I like using the last 5. So looking at those, now we have a fantastic view that's showing us where each salesperson is currently, but also where they've been before. So we mentioned Priscilla Taylor before. She has started out in kind of this leaders quadrant where she was doing really well on contracts sold. She was also doing well on her close rate, but she's only gotten better since then. For Marianne James, she is closing like a champion. So when she goes on an appointment, she is very likely to sell, but she's not selling that many contracts, so we need to push more leads her direction. This also lets us see people like Michael Smith, people like Laura Yeager, who really are underperforming, and we may need to have a discussion about what we do with them going forward. But this chart actually has a special place in my heart, at least in terms of data visualization. the company that I used to work for was trialing Tableau. They wanted to use it. They wanted to see what it was useful because we had a very well-respected DBA who had worked with it before and was recommending it. He was brilliant. So we're like, yes, we need to make sure that we look into this product. We got in the free trial. We connected to a few data sets, and it was useful, but not really showing much compared to what we had through other solutions. But then we built a matrix very similar to this. It had close rate, it had contracts sold, it was on a monthly basis, but the principle was still the same. And at first, we were just really excited because we built a cool chart. But then all of a sudden, our cubicle started getting very crammed. We had members of not only our team, but ended up having the entire executive team inside of our cubicle sitting there watching these dots change over time, watching this performance tracking. And it ended up being an amazing experience where everybody saw data in a way that they had never seen it before. There's something that the visualizations from Tableau give you that we ended up buying Tableau right away. And we used it ever since, and it more than paid for itself through creating visualizations like this and other opportunities, like I mentioned with the executive team, to show them our data that we had seen before, but in new ways that really led to quick insights. So we'll call this our salesperson close rate and contracts sold. Great. So at this point, we've actually gone through everything that African Mobile has asked, but then you have a challenge. Turns out your boss has recognized that African Mobile has long experience with Tableau and they're not easily impressed. So she's asked you to cap your workbook off with a Sankey chart, showing how sales flow between segment and region to really blow them away. For those of you unfamiliar with the Sankey chart, come here and we can show a quick example. A Sankey chart shows the flow of one of your measures or some value between two different segments. So here we have it flowing from electricity and gas to, rather than two different segments, two different dimensions. So we have it based off of the dimension of what type of energy you're using and then what that energy is used for. So we have electricity used for heating, lighting, and food storage. We have gas used for heating, used for water heating, laundry, and for cooking. And so it's a really visually stunning graph that maps it with a beautiful S-curve going across and really makes your data pop. Granted, there is some debate about how readable this chart is. I'm not going to address that right now. I'm just going to show you how to go in and how to create this in Tableau and leave the use cases up to you and based off the needs of you, your company, and your clients. It also is worth mentioning that this Sankey chart in Tableau is not one of the built-in charts, which is why your boss wants it, because it's a really kind of powerful thread. But it's worth mentioning, and credit is due to people like Jeffrey Schaefer, Olivier Catherine, Noah Salvatera, Joe Mako, and Chris Love, whose technique we're going to be demoing, who have contributed a great amount of time online, posting tutorials, and really putting in the mathematical development to create something like this and push the limits with what Tableau has. Anyway, so enough of an introduction on that. When we're looking at a Sankey chart, we have our data, like I said, flowing from one dimension to another. So going back to the request, we want to show sales flowing between segment and region. In this case, we're going to have segment on this side. We're going to have region on this side. Now, how Tableau interprets data, in order for the Sankey chart to work, you're actually going to need two copies. One copy of your data for your starting point on segment, and another copy of your data for your starting point, for your ending point on region. Now, if we wanted, we could come down here and we could select our entire data set, copy it, and then append it to the bottom so that we now have two copies of everything. But that runs into issues, especially if the data changes or if it updates at some point, then we have to go back in and redo that manual work with Excel. And so we wanted to actually demo a way to create that duplication of the data that we want, as well as some additional fields that we need using Tableau's built-in capabilities. So coming in, we're going to need to go to our data tab, connect to a new data source, connect to an Excel file, and we want our African Mobile data. However, instead of clicking open like we normally do, we're going to come down here and open with a legacy connection. So in the past, Tableau connected to Excel file using Microsoft's Jet engine. And what this did was it introduced different possibilities that turns out they didn't need anymore, so they discontinued it in future versions. But they left that legacy options still available for us, and in this case, we can leverage it for what we need. So just to help keep things different, we'll name this data source our Sankey data set. And now we have our sales data. You notice it's just like the other data that we brought in. We have 1,056 rows, starting from 2013 down to the end of 2016. And then we're going to leverage what I said about that custom connection. When you come up here and look at the data tab, there's a few options that aren't available normally when you use Tableau's new Excel connector. One of those is a convert to custom SQL option. What this does is it shows the query that Tableau is using to connect to your Excel file, written as if it were in SQL, a structured query language. So for anybody who's not familiar with SQL, the basic syntax is you select a bunch of columns from a data source. So this is just selecting everything from our Excel file. You'll recognize our column headers here, bringing it in from the Sales Data tab. Now we're going to copy this, pair it with union all, which says append everything from this second group of text, and we'll just paste this connection from before, effectively duplicating what we already had. So if we hit OK on that, you can see our numbers have now gone from 1,056 to 2,112, duplicating our data like we needed to have happen. Now, going back to our Sankey chart, we're going to need to know which data set exists with which one. So we need to know which side of the Sankey chart we want our data to be on. In this case, we're, again, doing segment connecting to region. So I'm going to go back in to our custom SQL query. I'm going to add a column. So first we say segment as viz side. And then down here, we're going to say region as viz side. Now this viz side is just a filler. I could name this anything I want. I could name it baseball if I wanted. It really doesn't matter. But viz side is kind of a contextual clue for how we're going to be using this column. So it's always a best practice to not name it something like baseball, but actually name it something that will help your users and help you in your data prep process. Also important to note for those who don't know SQL, you need a comma between your columns. So we have a comma here, and then lastly, when you're unioning, you need all the column names to be the same. So this is viz side, this is viz side, and we click OK. Notice it adds a new column. So we have viz side for segment, and then we have viz side for region. Again, going back to our view, we now have the left side of our data set, and we have the right side of our data set. And we're able to use those to develop the Sankey chart even further. So now that we've duplicated the data, we've basically taken care of our vertical data sources that we'll need. We'll be able to calculate a percent of total for the segment, a percent of total for the region. But what we're going to need to do now is create these marks that go across the view horizontally. There are multiple ways to do this, but the best way to conceptualize it is to think about when you drag like month of date up to your view. We'll go back to our profit trend. And if you look at this, you see we have month up front and then the sum of profit. What Tableau is doing is it's going through, and for each individual month across this horizontal axis, it's looking to our data set and pulling in the sum of profit. So for commercial month of August 2013, the profit was 175. Looking back, though, at this sheet, we have our vertical data set, but we don't have anything horizontally because there's actually no scale that's going on between these two. So what we're going to need to do is we're going to need to create the data that goes in between these two charts, creating the flow back and forth. Having done this before, you need to write about 50 marks to make it flow nice and smoothly and create the nice S that we're looking for. If you have fewer, it ends up looking jagged. So what we need to do is create the values 1 through 49 in our view. And there are multiple ways that we can do this. Sorry, not in our view, but in our data set, and then in our view. One way to do it would be to go into our Excel file, join it to itself, and duplicate every single row 49 times, label them 1 to 49, and then that would give us the marks that we need to draw these lines. That massively increases the size of your data set, going from whatever number of rows you had, multiply that by 49, and you can run into some major performance issues. So we're going to use a more advanced technique that's called data densification. This is something that Tableau will recognize as not a master technique, but they'll call it a Jedi level technique. It's something that is very powerful, and it helps Tableau write data that isn't there. So we're going to come in and we're going to create a field called to pad. This is basically creating the endpoints between our two ends of the line that we want. So looking to Viz side, whoops, I don't need that yet. I need to be using our Sankey dataset. Sorry, 2pad. If Viz side is equal to segment, so starting with the left side of our view, then we want it to be 1, else 49. So what we're doing right here is creating our endpoints. We're saying on this side it's going to be 1, on this side it's going to be 49. If we come here, we drag the pad up to columns. Make that discrete. And then you can see our number of records. What we've done is created, as expected, 1,056 is the number of records that are associated with 1, so 1 copy of the data set, and 1,056 values for the second copy of the data set, which is 49. But what we need to do in order to build this S-curve, we need to have access to those discrete values between these two numbers, so between the 1 and between the 49. So we're going to come down to our 2pad right here, and we're going to create bins. So bins are familiar for anybody who has used a histogram before. But the bins function has a special capability in Tableau in that it is range aware. So if we look at our view now, we have our values at 1 and our values at 49 like before, except this time, now we have all of the values in between. When I say it's range aware, that means that Tableau's bin function looked to pad and said, okay, we have a minimum value of 1, a minimum value of 49, and so we want to create data for all the other values in between, even though it doesn't exist in your data set. So in effect, we've created those other 48 copies that we need without actually copying any data. This does put a little bit of strain on Tableau's data engine, but when you're working with smaller data sets, it's totally fine. And it's a really incredible advanced technique that we'll show more of as we go throughout. Now working with this, we also need to create one more calculated field. I'm going to call it T for reasons that we'll see later. And we'll just use index, which returns the current row of the partition. That's just a way to track your data as it goes across. Call that index over 25, index minus 25, sorry. And then we'll divide that by 4. This is a technique that's known as jittering. It takes the relative position of your mark, moves it a little bit, and then divides it by another value so it moves the position of your mark just a little bit. What in effect this does for our Sankey chart is it evenly spaces all of our marks across the view from left to right. So now we have T. We're going to drag padded over here to detail, give it a number of records, and we'll drag T up to columns. Now you notice that it's a table calculation. Index is a table calculation. So if we compute using table across, we only have our 2 values. But then if we compute using padded, which is that data that we densified, and then change it to circle, we'll find that whereas before we only had our 2 values, we now have a value for 1, 2, 3, 4, 5, all the way up to 49. Looking back to our example, it's always helpful to reference back to the picture that we're looking for in the end. We now have all of our marks across this view that we need. Again, incredibly awesome tool. Data densification is a really impressive and very technical skill that if you have, it will really impress people who are looking to understand how well you understand Tableau. So this is very exciting. And now that we have the horizontal worked on, we need to drop back to our vertical, because the vertical data set also needs to understand how electricity and gas sort themselves. So we'll have these subcategories, and you have a value from 1 to n, depending on how many categories you have. And for the Sankey chart to work, you need to have that value on your left side with your segment and on your right side with region. So we're going from 1 to n, and then in order for there to be a nice flow to create this curve, rather than just straight lines across, we'll go from 1 to n on segment, and from 1 to n going the opposite direction on region. So to do that, we'll create our rank functions. And for these, the request has been to just look at our sales over time and how they flow between the 2 dimensions. So we're going to show our sum of sales and divide it by our total of our sum of sales. For those familiar with table calculations, this is just a sum of your sales across your data set, across your view, sorry, and then divided by the total, which is the sum of sales in the entire data set. And so you end up with a percent of total that will work for you. So that's rank 1. And then we're going to duplicate that and create the same thing, and we'll just call it rank 2. It's the exact same field. All I've done is duplicate it and rename it. So now we have T, we have rank 1, we have rank 2, we have padded. So we have the functionality to inform where the locations are on either side. Along with that, though, we also need to program in this curve that's happening. So this curve is actually something called a sigmoid function. From Wikipedia, it's just a mathematical function having an S-shaped curve. You can see it right here in this example. Often refers to the special case of logistic function, shown in this figure again, and defined by this formula. This is the exact formula that you're going to use. And if you're skipping ahead of me, you've noticed that it has a T in there. So that's why we called that other column and that other calculated field that we created T for use in this calculation. So we're going to call this the sigmoid. And we want to make it 1 over 1 plus, looking back at our reference, e to the negative t. Tableau doesn't have a built-in e function, but it does have exponent, which exponent returns e raised to the power of a given number. So if we say exponent 1 raised to the negative t, then we have our sigmoid calculation. This, again, is just giving us the curve in our line. So we're actually going to need one more calculation that actually returns the actual curve. So the curve is dependent on where you're starting and where you're going. So just in this quick example, if this is 1, 2, 3, and this is 1, 2, 3, 4, 5, 6, 7, 8, if we want to go from 1 to 8, the curve function needs to understand that. And we'll use our 2 ranking formulas to tell that. So our curve is going to be equal to our first rank plus the difference between our 2 ranks times this sigmoid. So basically times that curving function. This rank 2 minus rank 1 effectively swaps the direction of your second rank. And so you're running from top to bottom on the left side for segment and bottom to top on the right for region. So that was a lot. If you're still following, give yourself a high five. If you're not quite following, keep watching. We're about to get something more visual rather than just technical and dealing with a lot of calculations. So we can now start by adding our 2 dimensions that we care about to the view. We have segment and we have region. And then we're going to add our curve to our rows. Right, so if you look back here at our chart, our curve, this S-shaped part of the Sankey chart, needs to go across these rows that we've created. Now, if you add it at first, you'll see we're really having issues. There's 705 nulls. You only have 2 marks showing up on the screen. And that's because to make curve work, you actually need to come down and edit table calculation and use something called nested table calculations. Nested table calculations give you the ability to work with different fields and treat them differently depending on how the table calculation accesses them. So for instance, we can choose rank 1 and say, here's how this table calculation curve will behave when it's looking at rank 1. Here's how it will behave when it's looking at rank 2. Here's how it will behave when you're looking at T. So let's start with rank 1. With rank 1, we don't want table across because we don't actually have all the values in our view that we need. We needed to comprehend padded. But we also want to specify the direction. So we want to go from segment to region and also include padded. Then you click and you drag this up to the top to create that order that we were just talking about. So now we have our segment, we have our region, we have padded, and you'll see this is a little preview showing up to where we're starting to see marks show up on our screen. It's very exciting. Bring this over to rank 2. We're going to want to do very similarly, except this time we want region to show up and then segment after that. Now, as we order the way in which these communicate with each other, all of a sudden we're starting to see some very exciting things happening in our view. And the T just makes sure this computed across padded so we have the entire left to right version of our marks available to use. So looking at this, all of a sudden we're starting to see a Sankey chart. We have our values from 1 to 49. They go across the view, and then when they need to flow differently, they are using that sigmoid function to create the curve. Now at this point, I'm going to take a little bit of a break. Just going to clean some stuff up, allow people the chance to kind of think about what we've been working on, and hopefully this all is making sense. It is not an easy topic, so well done for attempting something this big. we're going to clean this up by going in, fixing the axis at -5 and 5. That gets rid of this kind of jump right here. That has to do with the data densification and how Tableau handles it. So if we do -5 to 5, we're not losing any additional value because we don't need those extra marks. We just needed the marks to build the curve across. Then you can come down and you can hide your header. For the curve, we also want to go through and make it take up the entire view. So because we know it's a percent of total, we know it can just go from 0 to 1. And then we can also come in and we can hide the header. But one thing I want to work on really quick is that if you look right here at our top marks, we have our residential segment. In the center, we have our public segment showing up. And then in the bottom, we have our commercial segment. Going back to our profit dashboard, that's actually the opposite of how it normally shows up alphabetically, commercial, public, residential. That just has to do with how Tableau handles the ranking function. So we can fix that really easily by coming in, reversing the axis, and now we have commercial, public, and residential, just as a way to keep consistency across our workbook. So get rid of the curve header right there, and now we have a great looking chart that is circles for now, but we'll go in and we'll change it to line. And then everything breaks. This is kind of common as you're practicing with table calculations, as you're working through nested table calculations, different dimensionalities, different levels of detail, things like this, maybe not this exact view, but your view breaking will be a very common symptom. So don't feel bad if you ever get there. I do it all the time. What's happened is we're now drawing marks as best we can, but Tableau still can't comprehend how it's supposed to draw between these marks, right? So it understands that there's a value of 1 here somewhere. There's a value of 49 as well, but going in between the marks, it doesn't really know what to do. Turns out if you drag padded over to path, then it tells Tableau, draw the line over that data densified data you created for padded, and now you have this amazing looking Sankey chart that's showing up. Very exciting. We're almost done. So hang in there if you're falling behind a little bit or if you feel like you have questions. What we now need to do is, if you look back at our example again, from this width, it's actually sized by the percent of total, or sized by the individual value inside of each line. Now we want to do that, but if we drag sales up and try and put that on size, you notice we have a problem. If you look in the tooltip, you see that sales are blank. This is a similar situation to our salesperson comparison. When we first built the difference from selected without the level of detail, what was happening was it tried to sum up the values for Francis Martineau when your salesperson was equal to Constantine Eager. And so since there was no value there, it didn't return anything other than a null. In this case, the value of 13 doesn't exactly exist in our data set anywhere. And so when Tableau goes to try and sum sales, it doesn't work. And it returns nothing because it didn't find anything. But we know that these values exist in terms of the densified data. So what we can do is we can trick Tableau into providing the data that we need. So we'll call this the sizing for sales. What we'll do is do a running average of the sum of sales using, again, a table calculation. Drag that up to size. Have the same issue as before because we're calculating for table across where the values don't exist. But if we bring it down and tie it to our padded data set, now, if we increase that, you'll see that there's a relative size difference between things. It's able to comprehend where we're looking at across our view and then size our marks accordingly. So we'll come in, we'll clean this up a little bit. We'll go in, we'll format, get rid of our grid lines. We'll get rid of our 0 lines. And then to really top things off, we'll add in our color for segment, but also for our region. And now we have this great view, our Sankey chart, where our sales are flowing from our segment on this side to our region on this side. So high five everybody for keeping up this long. This is not a beginner's chart, and it's fantastic you've been able to join us for this. But leaving it just like this, while interesting, doesn't provide as much helpful information as could be possible. The way to really make this pop is to combine it into a dashboard. So we're going to rename this as a Sankey sales chart, Sankey sales flow from segment to region. And then what we want to do, looking back to other example, is we want to create these percent of totals and then wrap your chart on either side with them. So This should be more straightforward than other things. We will have our segment right here, and we'll add in our sales. Sorry, we'll drag segment to color there. You'll notice that it's using its automatic color pattern. We will need to change that to green just to match the styling that we have on the other sheet. Now we can add our sum of sales, but we do want to make sure that this is a percent of total. Drag up to the top. And then we'll also add segment to our label. Coming out of percent of total, we'll come in and clean this up a little bit. We want it to be a percentage, but we really only need 1 percentage point. And then it might be helpful to list the segment first. So now we have a percent of total by segment that we can then use as a reference in our dashboard. So we'll call this segment reference. Then we'll just duplicate that sheet, and instead of segment, we'll call it region. Add region to detail. I'm removing the colors for reasons that will be seen in a second. And we have our sum of sales, again, being computed using our table down to get our percent of total. So now we have our segment reference, we have our region reference, and we can create our dashboard. So add in our Sankey chart first. We'll get rid of these values, these legends, sorry. And then we'll add in our segment reference, and we'll add in our region reference. Close that out again, because the colors are labeled, so we don't need the extra info. And then to make things line up, we can get rid of our headers. And then we'll also hide the title. And then we can play around a little bit. Again, we'll make this automatic. Fill our view a little bit nicer. And then now we have our flows from commercial over to the different regions. And we have our flows from, we have the flows from commercial, from public, from residential, from all of our segments over to our different regions. And then you see where the reason that I chose to not do anything with colors on our region reference was because if you had blue flowing to both blue and green and orange and red, it would confuse things a little bit. So coming back here, looking at our color palette, we can actually drag region color, but instead of our colors that will clash with what we're using, let's just apply the grays color palette. And now on our dashboard, we can see the flows going back and forth. Now there's one more thing that we can do to make this really interactive and really highlight the flows that are happening. We can go in and we can start using some dashboard actions to highlight what's going on. So we'll add an action, not a filter, but a highlighter. Call this our segment highlighter. And we'll use the segment reference as our base chart. And we want it to apply to our Sankey sales, but then leave our regions unchecked because we want to still see all the different regions. We just only want to highlight the segment that we're interested in. Adding a similar thing going the other direction, we want our region highlighter. We'll go from region, uncheck segment, and then have it on hover. Now with these actions, we've added a whole new way to interact with our dashboard. If you hover over commercial, you can then see your sales flows as they go from commercial to public to residential. You can also see them moving the other direction across your different regions. Now I'm going to go in real quick because we have the highlighting doing the action that we want. I'm going to remove the tooltips because those are just getting in the way. And then right here, last step, remove that tooltip. Come back to our dashboard. And now we have this great looking Sankey chart that hopefully will blow away our customers and will really show them we know what we're doing with Tableau and that there are very exciting possibilities in the future working with us. So that is our case study today. That is our workshop on working through Tableau. We've covered everything from interactive dashboards to sheet swapping or measure swapping or dimension swapping, which is what this is called. Then you have your salesperson comparison with level of detail calculations. You also have interactivity built in with parameters. Here we have our pages functionality to show animations over time. And then at the end, we capped it off with a Sankey chart. So thanks for attending, everyone. It was great to have you joining us. Hopefully you can use these techniques in the future. Recordings of this webinar will be available on superdatascience.com. And hope to see more of you guys in the future. Again, just looking through, it turns out there have been a few questions. My colleague has been working with you guys to answer those real quick, and there's only a few left, so it looks like we're doing well. Feel free to submit your questions. I did have to go through things quickly just because of the amount of content that we're working with. So if you want questions, feel free to submit them through GoTo. You're also welcome to email us, get in touch with us afterwards, and we'll be able to answer your questions on a one-on-one basis as well. Okay, so we had a question come through. What's the best way to close the gap between the references and the start of the Sankey? This is one of the limitations of this approach and just of doing a Sankey chart in general. You're going to have to play with manual sizing. So you have to come over here, and rather than having it fit the entire view, you're just going to have a standard, and then you'll go in to your segment sheet, and you'll size this appropriate for whatever you need. You can make it wider right there, and then coming back to our chart, it then will connect all the way up to the edge of your view. And then you can close that gap right there. I didn't do that because, for one, in interest of time, but also because if you're using different devices, then that gap sometimes can show up even though you've eliminated it on your device, especially when you're working on a laptop like I am connecting to desktop users. The way to completely remove that is to actually change this from a right over here, rather than a tile layout container, making it a floating layout container. And then you expand that out to fit your view. And again, you can see it's a very manual process. It is one of the limitations of how the Sankey chart is built in Tableau. But if you do it with floating, then you'll be able to clean up that gap and remove it entirely so it looks like it's flowing straight out of segment over to region. Okay, along with that, some of you have asked if these files will be available on Super Data Science afterwards, and of course, this Tableau workbook from the webinar is going to be saved and packaged online so you can have it and access to it. You also will continue to have access to the data as well as the questions so you can go through and practice it yourself. Those data files, the Tableau workbook, they'll also be posted with a recording of the webinar, so you'll be able to work through along with me to mimic what I do, to follow it, and hopefully be able to nail down that technique. And ideally, you can find ways to do it better than the ways that I did it, and you can send us feedback, and I can learn from you guys as well. Just a quick thank you to everybody who attended as well, and your interactivity and the questions that you've asked. It really helps us to create a better product for you, but also to show visualizations, to show ideas, and to show ways of working with Tableau that you guys are interested in. And we'll really be able to respond to what you guys want and what your demand is. So it's very helpful for us. Thank you. So we have another question coming in about any restrictions that exist. And the wording is a little bit vague. So it seems like the question is asking about, are there any restrictions on how you can use Sankey charts, especially when you're worried about kind of the technical performance? Tableau, I think I'm interpreting that right. Okay, so if you look at your restrictions on Sankey, I mentioned a couple times that you can run into problems very quickly with performance, especially if you're duplicating a lot of your data or if you're dealing with a very large data set. So this technique where you apply the data densification is a fantastic and advanced technique, but it can run into issues when you try and ask Tableau's data engine to do too much. There's another method piloted by Olivier Catherine, whose name I mentioned earlier, who uses, rather than data identification to create the marks, actually duplicates their data a bunch of times to draw individual lines, but then only takes the top line and the bottom line and then fills it in between with a polygon to make a much more performant Sankey chart that's able to match big data sources a lot better. So I'd recommend looking up his stuff, Olivier Catherine, Sankey. Just Google that really quick and you'll be able to find his technique. We're also hopefully going to be able to do a tutorial on that going forward, where you can show the other way to create the Sankey chart. That one tends to work better for really large data sets. This one is better suited for specific data sets and relatively smaller. The restriction will depend entirely on your computer, on your processing power that's available. A kind of ballpark rule is 5,000 rows, but it's 100% up to your computer and how you work with things. And okay, that covers all the questions that we have. Again, thank you everyone for attending. It's been awesome. We're super excited about the demand that has happened and the number of people we've had attend. It's been awesome working with you and walking through this case study together, and hopefully we'll see more of each other in the future. Thank you.